Hi, class. Today we're going to talk about just kind of the transition from cosmological arguments to design arguments. And so this video is intended to replace the discussion day we had on 4.6, or I shouldn't say replace, but uh, conveys the key material that you should be talking about in the discussion boards. So, as we have seen, cosmological arguments try to do something very specific. They try to argue that some sort of general or perhaps pre-scientific metaphysical fact about the world implies some sort of first being, and they do so using the principle of sufficient reason. As such, that makes them deductive and a posteriori. Also, notice that even if one is successful, you still need a lot more argument. Well, unmoved mover certainly doesn't tell you anything about morality, for instance. And so one thing that all cosmological arguments have in common is they get you to a first being and that's it, which means you would need a lot of extra argument if you wanted to get a very specific description such as the God of theism. So, in terms of discussing these, what kinds of questions should you be talking about? And these are the kind of things you should probably be posting in the Craig's Kalam discussion thread? Well, what we're always interested in philosophy. Are these arguments sound? Why or why not? If it's not sound, we have no reason to accept the conclusion. And so I would like to see some talk about whether you think each argument is sound and why. You should certainly be able to do a discussion response on that, and it's the kind of thing that would be fair game for the final. So be sure you can talk about those intelligently. But also, you should be able to talk more generally. How do cosmological arguments seem like a good approach? Does this seem like a good and helpful way to figure out if there's a higher power or not? I would love to hear those more general thoughts as well. By contrast, so think of the approach we just described with cosmological arguments, and now we're going to contrast that with design arguments. So if you want, you could also talk about which one seems like a better approach and why. So design arguments uh, are pretty. They have more variety in them than cosmological arguments do, so it's a little harder to generalize. Um, but in its biggest, most broad brushstrokes depictions, cosmological arguments try to say that a higher power is a good answer to the question, why is there something rather than nothing? By contrast, design arguments try to say that a higher power is a good answer to the question, why is the world this way? And by the world, we mean something very broad here. We could be talking about the laws of physics. Why are the laws of physics this way? Or why is the human eye this way? And so, in general, it is a different question. And so, what do design arguments tend to have in common? Well, first of all, if they're talking about things like the laws of physics or the human eye, they're certainly a posteriori. They have to involve facts about the world. However, the best versions are inductive. So remember, the problem with Aquinas' fifth way is precisely that he tried to present what should have been an inductive argument deductively. So remember from Unit 1, there is nothing wrong with induction, and as we're going to see, these inductive arguments tend to be better than deductive arguments in terms of trying to argue this type of point, because it's about the world. So they're inductive, they're a posteriori. What do they do in general? They try to show that specific facts about the world, not these big general ones, but very specific, usually scientific facts about the world imply a designing mind. So if a design argument is successful, it already gets you to something like a human intellect in certain ways that is intentional and deliberate, etc. But overall, that's what they do. So they take some very specific fact, usually a scientific fact, try to show that either the best explanation for that is a designer or that such facts make a designer likely because it's inductive. So that's what these arguments do in general. And as I mentioned, there's a wide variety of these arguments. They could start with something very specific like the structure of the human eye, or they could also do things very generally, like laws of celestial mechanics and how the planets move. So it takes all kinds. I will not say the only, but I will say the best design arguments are arguments by analogy. And so before we get to the Paley, which is the next reading, we really need to understand some about analogy. So first of all, before I forget, the next reading is online. There's 2 chapters of the William Paley reading. The first chapter is required. The second one is actually optional, where he gives a different design argument and addresses some standard objections. So make sure you read the first one, and I'll tell you what to look for after we talk about arguments from analogy. That's going to be the really important part here. So, obviously, inductive arguments from analogy are inductive, and every argument from analogy fits a certain form. So, try very hard right now to just set aside design arguments and think more generally. Every argument from analogy argues as follows. And you might want to write this down. Entity A has properties L, M, and N through some Z. There's some dots in there because there's not a fixed number. It doesn't have to be 3. So entity A has properties L, M, N through some Z. Entity B has properties L, M, N, ... Therefore, entity B has property Z. So, one more time for if you are trying to write this stuff down. Entity A has properties LMN ... through some Z. Entity B has properties LMN ... Therefore, entity B has property Z. Every argument from analogy can fit that form. So let's talk about it in more detail. What is that argument doing? If you remember from Unit 1, arguments from analogy try to go from known similarities to an inferred similarity. And that's exactly what we've represented. So if you want to break down an argument from analogy, start with property Z. Start with the inference. So property Z is what we infer B has. Then entity A is what we know has Z. Entity B is what we infer has Z. And then the LMN ... are known similarities. That's the very, very general idea. So, let's do just a couple of examples of how this works. First of all, we use it all the time. Analogical reasoning is overwhelmingly common. We just don't realize it. So think of lab testing on rats. You might say, the rat has properties A, B, C, etc., such as a certain type of circulatory system, and the drug helped its cholesterol. A human has the same kind of circulatory system, therefore, the drug will help humans. So notice, what's our Z? What do we not know but infer? Whether the drugs will help humans or not. If we want to make that kind of argument, what do we need? Something we know the drug helps with the cholesterol, that is the rat, and some similarities, specifically the circulatory system. Or let's say I'm trying to conclude how this class will do on the final. Well, what do I need? A class that I know how they did on the final. I might, for instance, use my intro class from last semester. So my class from last semester is entity A because I know how they did on the final. You would be entity B, the one I'm inferring how you're going to do on the final. And then we would need some similarities. So you might talk about things like, well, it's the same instructor. That's important. It's roughly the same material, same exam format, etc. Now, that's how arguments from analogies work and break down. What we haven't talked about is how to evaluate them. Because you might be saying something like, well, wait a minute, this class is finishing online, last semester did not. How does that fit in? When we are evaluating arguments from analogy, we're really evaluating 2 things. The relevant similarities, that is number and whether they are relevant or not, and absence of dissimilarities. So let's just give an example that tries to bring this out. Suppose I made the following argument by analogy. Adolf Hitler had a mustache, was a teetotaler, and was a genocidal madman. My good friend who works in bioethics has a mustache and is a teetotaler. Therefore, my good friend who works in bioethics is a genocidal madman. Why is that a terrible inference? Two reasons. One, the similarities are not relevant. Relevant to what? Relevant to Z. So whether you have a mustache or not is not relevant to whether you're genocidal. Whether you drink alcohol or not is not relevant to whether you're genocidal. And so the first problem is the similarities identified just are not relevant. But there's a second problem. There's a big dissimilarity. That's why I kept emphasizing my friend who works in bioethics. Professional ethicists are much less likely to be moral monsters. And so the similarities are irrelevant and the dissimilarity is relevant. So that's why it's a bad analogy. So overall, we look for relevance, make sure the similarities are relevant, make sure there's not relevant dissimilarities. One thing I want to emphasize, I mentioned it, but I know these go pretty fast. There's no such thing as relevance or irrelevance in general. There's only relevant to Z. For instance, having a mustache isn't relevant to whether you're genocidal, but if you were trying to make the argument that Mickey looks like Stone Cold Steve Austin, well, then having a mustache is very relevant. And so there's no such thing as relevance in general, only relevant to Z. All right, so far so good. That's analogies in general. Now let's shift to what Paley's going to do. Paley is going to try to argue that the universe or some part of it is designed. Well, wait a minute, that's his conclusion, which means that's his Z. That's the thing he is inferring. He is inferring the universe or some part of it is designed. How would we draw an analogy there? Well, we need an entity A and an entity B. What is indicative of entity A? It is something we know is designed. So Paley's going to use a watch. It's something we know is designed. Entity B is the thing we are inferring is designed, so it's going to be the universe or some part of it. Well, that's easy. What do we need? Now we need those similarities, and they need to be relevant. All right, so here's where Paley's brilliant. Watch for this. He's not only going to give a list of ways in which the watch is similar to the universe, he's going to go much farther than anybody else up to the point of his writing. And he's going to prove, he's not just going to assert, he's going to prove that those identified properties are relevant to design. And the way he's going to do that is he's going to introduce a third entity. So when you're reading the Paley, watch for two things. One, be ready to populate the list of these things he says are relevant similarities between the watch and the universe. But two, we're going to start the evaluation by starting where Paley did. Well, how is he going to introduce this third entity that is going to help us figure out whether these properties are relevant to design or not? So that's what to watch for, and after you've done that work, watch the next video and we'll see how you did.